Hi, welcome to the first trigonometric tutorial. Today's tutorial is titled Basic Trigonometric Identities and the Cartesian Plane. We are going to be looking at the basic trigonometric identities and how they translate onto the Cartesian plane. Note that the Cartesian plane is just a system of axes. In terms of what you need to know, you need to be familiar with your grade 10 work on trigonometry, and I'd also recommend you go through the section I've included called Using Your Calculator. Reference to this is made in the DVD workbook. What is trigonometry? Trigonometry is a science that looks at the relationship that exists between the angles and sides of a triangle. Initially, this science was developed primarily around the right-angled triangle, but has been further developed to include almost all triangles. We will begin by looking at the basics of a right-angled triangle and progress on to the three basic trigonometric functions of sine, cos, and tan. Take a look at this right-angled triangle over here. Firstly, the most important thing about a right-angled triangle is the fact that it has a right angle in it, and I'm going to put that over here. Opposite the right angle, the side opposite the right angle is always the hypotenuse. Now, I'm going to draw in an angle theta. Theta is just a Greek letter that can denote an angle. Note that we could use theta, we could use beta, we could use alpha. We could also use any other variable. We could use x, y, we could use z, s, t, up to you. The side that is opposite that angle is referred to as the opposite side, and the side that is next to that angle is referred to as the adjacent side. So in this triangle that we have now, of theta, the hypotenuse is always the hypotenuse of the right angled triangle, the opposite side is over here, and the adjacent side is over here. I'm now going to change that slightly. I'm going to look at this top angle over here. Let's call that S. Of angle S, this side is now the opposite side. This side is now the adjacent side, due to the fact that the opposite side is opposite angle S, and the adjacent side is adjacent to or next to angle S. The hypotenuse is still the hypotenuse. Now remember, earlier I said that trigonometry is a set of relationships that exist between angles and sides of a right-angled triangle. We are now going to look at those relationships. The first relationship we will be looking at is that of sine. Sine deals with a relationship between the opposite side and the hypotenuse. Sine of any angle in a right angled triangle is equals to the opposite side divided by the hypotenuse. Cos is the relationship that deals with the adjacent side to an angle of a right angled triangle and the hypotenuse. Therefore, cos of an angle is equals to adjacent over hypotenuse. Tan is the relationship that deals with the opposite side to an angle in a right angled triangle and the adjacent side to that angle. Tan of an angle is equals to opposite over adjacent. Let us see how this translates to a right angled triangle. Again, I'm going to use the right angled triangle that I used above. If I draw in theta over here, sine of theta will equal opposite over hypotenuse cos of theta is going to equal adjacent over hypotenuse, and tan of theta is equals to opposite over adjacent. These relationships always hold true, and I want you to memorize this. One way that I learned to memorize this was at school, where I learned this rhyme: silly old hens cackle and howl till old age. You are welcome to learn any rhyme you need to, or just learn it as is, but always remember that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. We are now going to look at some simple calculations involving the basic trigonometric functions. I want you to have a go at the following examples. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you to do read sine of 40. Now sine of 40 degrees, if you punch it into the calculator, you're just going to literally type sine 40. And that's going to give you an answer of 0.64278. So I'm just going to round it off to 0.64. The second one was cos of 80. Cos of 80 degrees, again just type it into your calculator as cos of 80, which will give you an answer of 0.17. Number 3, tan of 20 punched into a calculator is equal to 0.36. Now if you are not getting the answers that I'm putting up here, I would suggest you go through the tutorial I've included called Using the Calculator, because possibly your calculator is not in the form DEG, which stands for degrees. The next one, sine of 50 is equal to 0.76, actually 0.77 if I round it off. Number 5, cos of 40 is equal to cos of 40 is equal to 0.77. Where have we seen this one before? Haha. Notice that sine of 50 is the same as cos of 40. Just out of interest, sine of 30 degrees, if you punch that into your calculator, is going to give you an answer of 0.5. Type in cos of 60. That's also going to give you 0.5. Look at the relationship 50, 40, 30, 60. I'll give you one more. Sine of 10 degrees is equal to 0.17, which is exactly the same as cos of 80. Something for you to think about. Sine of 50 is the same as cos of 40, sine of 30 is the same as cos of 90, and sine of 10 is the same as cos of 80. Keep that in mind. The next 5 that I gave you to do were the opposite, where we had to use the inverse function. The first one was sine of x is equal to 0.5. To get x, we're going to say x is equal to second function sine on the calculator of 0.5, which if I type that in is going to give me 30 degrees. Number 7, cos of x is equal to 0.5. That means that x is equal to, again, 60 degrees. Number 8, tan of x is equal to 5. Second function tan of 5 is equal to 78.7 degrees. Number 9, cos of x is equal to 0.866. Second function, cos of 0.866, is going to give me x is equal to 30.003, or just 30 degrees rounded off. Number 10 said tan of x is equal to 1. That means that x is equal to second function tan of 1, which is 45 degrees. In the first 5 examples, we were using this simple function sine of a number, which was the degrees, which gave us a result. In this case, we've got sine of an angle is equal to something, and we are trying to work out what that angle is. We simply use the second function sine. On your calculator, it's called second function. It's not really second function. It's just the inverse of sine. The same way, when we have x squared is equal to whatever, in order to get rid of the squared, we square root it. That means that the square root is the opposite function to the squared. The same way, sine and sine second function on your calculator are the opposite functions of each other. Now let us take this concept and apply it to the Cartesian plane. In the next exercise that I gave you to do, I told you to sketch the angles given on a Cartesian plane. Now, in order to do that, we need a Cartesian plane. I've got one over here with an x-axis and a y-axis. On this axis, I'm going to include my basic angles, or my sort of references. 0 degrees starts over here. 90 degrees, notice that it moves steps in 90 degrees anti-clockwise. 90 degrees, 180 degrees, 270 degrees, and finally 360 degrees. 360 degrees and 0 degrees are the same thing. The first angle I asked you to sketch was 20 degrees. 20 degrees is going to come somewhere over here. That's 20 degrees, and that's the angle sketched. We don't need to put anything else on it just yet. 40 degrees is going to be double 20, and it's going to be somewhere over here, and that's the angle 40 degrees. 0 plus 40 degrees. The next angle we're going to sketch is 160 degrees. Now 160 degrees is going to go 0, 90, 160, which is going to come somewhere over here. That is the angle all the way over from there of 160 degrees, and it will have a certain x value and a certain y value. The next angle we're going to sketch is 230 degrees. 0, 90, 180, 230. That means that that angle is going to come somewhere over here, have a particular x and y value, but that is going to be the angle from 0 all the way up to 230 degrees. The last one, 315 degrees, is going to go 0, 90, 180, 270, 315. So it's going to come somewhere over here, and it's that angle over there of 315 degrees. Notice that all of these angles, the end or that point that makes up the line or the radius that subtends the angle, that has the end point has a particular x and y value. Now, sketching an angle on a Cartesian plane forms a right-angled triangle. We are now going to look at the relationships of sine, tan and cos, except instead of looking at it in terms of opposite, adjacent and hypotenuse, we are going to look at it in terms of x, y and r. R is essentially the hypotenuse. X and y are the coordinates of the angle given in terms of x and y. The first relationship of sine will look like this. Sine is equals to y over r. Why does that happen? Because notice of angle theta that we've drawn in, the opposite side is the same as the y value. Hence sine of theta is y over r. Just the same, cos of theta will be x over r and tan of theta will be y over x. Another silly rhyme that I learned from school, which you could use: sine your rear, cos x-rays, tan your exterior. That just means sine is equals to y over r, cos is equals to x over r, and tan is equals to y over x. Use whatever method at your disposal, but memorize these, it is very useful. I'd now like you to have a go at the following examples. Press pause on your DVD player, and when you return, we'll go through it together. Now this next exercise that I gave you to do includes both sketching the angle and drawing, or rather plotting, the points in. The first one, I said sine of theta is equal to 4 over 5. Now remember, sine is the function y over r. We know that sine of theta is equal to y over r, right? That means that of this angle theta, the y value is positive 4 and the r value is equal to 5 units. So all I'm going to do is I'm going to draw an r with 5 units. Now my coordinates are going to be as follows. R is 5 units, so I'm just going to choose 10 centimeters as being that, as being R is 5 units, and I'm going to look at where it intersects there. That means that this here is theta. It has an x value which we don't know and a y value of 4, because remember sine is equal to y over r. That means that my r, my radius, is 5 units long, and that is theta over there. Do we know what x is? No, we don't. If we wanted to find it out, we could by using the hypotenuse theory, which would be r squared is equal to x squared plus y squared. That means that x is equal to square root of 5 squared, which is 25, minus 4 squared, which is 16, which is equal to square root of 9. But that could be positive or negative. So x could be positive 3 or negative 3. I know that this is positive 3, but an r value of 5 and a y value of 4, positive 4, couldn't that also be somewhere over here? Couldn't theta also fall over here? That has a y value of 4, positive 4. It's still theta, except, and its r is 5, but look at its x value. Its x value is going to be here, negative 3. Same distance there and there, except now it's negative. So to sketch this angle, sine theta is equal to 4 over 5. It could be either that angle or that angle over there. The next one I gave you to do said that cos of theta is equal to negative 3 over 6. Now remember, cos is the function x over r. So we are looking for the x coordinate negative 3, which is over here, negative 3, and the r value of 6. Now at negative 3, that's that line over there, x is equal to negative 3. Our r value is equal to 6. So that means that we are either working with that angle over there, which is a theta of x value negative 3. So that's negative 3, and an r value of positive 6. Remember, r is always positive. To get the distance here of y, if we need to, we're going to say y is equal to square root of 6 squared minus minus 3 squared, which is equal to 6 squared, which is 36, minus 9 in the square root, which is equal to square root of 27. That means that y is equal to root 27, but because it's a square root, it can be positive or negative. Is that true? Yes, it is, because this line, this here, could also be negative root 27, which means that theta could also be over here, again with an r value of 6, but theta is over there. Both of them have an x value of negative 3. So theta could be either that one over there or that one over there. The next one I gave you to do read 10 of alpha is equal to positive 3 over 5. Sorry, positive 5 over 3. Now remember, 10 is the function y over x. That means our y value is 5 and our x value is 3. Y value of 5, x value of 3 means that our angle falls somewhere over here, and that is angle alpha. It has an x value of 3 and a y value of 5. If I wanted to calculate my radius, again, right angle triangle, all I'll do is I'll say r squared, in fact r is equal to square root of 5 squared plus 3 squared, which is equal to square root of 25 plus 9, which is equal to square root of 34. And r is always positive. But is this the only angle that adheres to that? No, it is not. The other possible angle that could adhere to that is negative 5 over negative 3. Wouldn't negative 5 over negative 3 also give us positive? Negative divided by negative is positive, right? So alpha could also come where x is equal to negative 3 and y is equal to negative 5, which means that alpha could also be somewhere over here. That's alpha. That is equal to negative 5, and that is equal to negative 3. R again will equal root 34. So there's two possible alphas. Notice the pattern with every single angle. Because I didn't give you restrictions and tell you in which quadrant to sketch it, there's always two angles. Either it's positive or negative. Keep that in mind. The next one I gave you to do read sine beta is equal to negative 1 over 3. Now remember, sine is the function y over r. That means that our y value is equal to negative 1. Our r value is equal to 3. That means that beta could either come over here with an r value of 3 and a y value of negative 1, and that would give us beta. Now, to get our x value, again, if we needed to, this is a right angle triangle, right? So x squared would equal r squared minus y squared. That means that x is equal to r squared minus y squared, which is equal to square root of 3 squared, which is 9, minus 1 squared is 1. 9 minus 1 is equal to root 8. That means that the x value, now it could be positive or negative. If it's negative root 8, that means that that x value is equal to negative root 8 is the same as 2 root 2, by the way. But x could also be positive. That means that it could also fit over here with an x is equal to positive 2 root 2, which means that beta could be over here as well. Again, two angles could be formed because I didn't give restrictions. Both of them have an r value of 3, and both of them have a y value of negative 1. The last one I gave you to do said tan of A is equal to negative 8 over 5. Now remember that tan is the function y over x. We are looking for y being equal to negative 8. That's over there. Y is equal to negative 8, and x is equal to positive 5. So that would be somewhere over there. That means that A would be this angle over here. That would be angle A, where x is equal to 5 and y is equal to negative 8. That means that r would equal negative 8 squared is 64, plus 5 squared is 25. 64 plus 25 is equal to 89 in the square root. That means that r is equal to square root of 89, and by the way, it's always positive. Is that the only solution? No, because what happens if x were equal to negative 5 and y were positive 8? Wouldn't that still be negative 8 over 5? So it could be y is equal to positive 8 and x is equal to negative 5, which would go somewhere over there, which means that my angle, well, actually it would go somewhere over there, which means that my angle A would be over there with an x value of negative 5 and a y value of positive 8. Again, r would still equal root 89. And that brings us to the end of the first trigonometric tutorial. I hope you had fun. The next tutorial is titled Reduction Formula. Go through the exercise that I left for you in the workbook before moving on with the next tutorial.